we'll take at least 2 breaks, short breaks here in the afternoon. But if I'm going too long, somebody please, give me timeout sign or something, because otherwise I just keep going and I keep talking. So with that, where we left off, we were in floor framing. And a lot of these points, we talked on the headers, a lot of these points about checking the tables, how they're working, they're going to apply for other sections. So keep that in mind as we move through. And what I wanted to just emphasize was a few points on floor framing, which the same principles apply to other sections. So for example, what you're seeing, hopefully you're seeing all my PowerPoint. Everybody got it with the beam? Seeing that? Okay. That beam is indicating the bearing. If I have a wood element resting on another wood element, I'm expecting an 1.5 inch minimum of bearing. Now, the way to keep this in mind is if I rested on a ledger, that would be a 2x ledger, meaning it's going to measure in actuality 1.5 inches. Or if you think of a joist hanger or some type of mechanical hanging device, that roughly is 1.5 inches in depth. So wood to wood, 1.5 inches minimum, meaning don't do it, but you could hang an element on a 2x2 nominal ledger, meaning 1.5 inches by 1.5 inches. So code would permit me to do that. But 1.5 inches wood to wood. If I am wood to concrete or masonry, and what we're seeing over here on the right is that fire cut that Chris was talking about. So I've got a 3-inch minimum of bearing on a wood on a masonry or concrete element. So it's 1.5 inches or twice that, 3 inches, if I was on masonry or concrete. Now, the only other thing here is if we have two members bypassing and they are intersecting at the middle and they're going to bypass, not butt in to each other or go and get hung on a header or a beam, but if they're bypassing each other over top and they get fastened to each other with face nails, that needs to be at least 3 inches. So 3 inches on the bypass, 3 inches masonry or concrete, 1.5 inches wood to wood. And that will carry you through for what happens when we get to roof conditions, for example, when we're looking at those. Y'all with me?
Is this drawing anywhere on the IRC where we can highlight these notes?
You would have to follow the section. So it's in 502.6.1. Does that help?
Yes.
Okay. So 502.6.1. And again, these are described in the workbook. And I'm just jumping ahead, trying to get through what's left in the book here. So I'll be skipping sections and expecting you to look at those things on your own as we move forward. But I'm going to hit some of the highlights, some of the big ticket stuff that we need to be aware of. So we got those bearing indicators, and what you'll have is you'll make reference to them in other chapters when we're talking about roof framing, but it may send you back to this chapter for these details. And that's what we do with cross-referencing. So I may not repeat everything again redundantly. I may just say, oh, installed per, and then send you to a previous chapter. So it may send you on a travels through the code, but it gets you to the same point. All right, so we had those elements there. Then I wanted to get into this idea. Here is my diagram about the cutting and notching. And here we've got an element with a load on it. And so it's creating stress on the element. And we get this idea of tension and compression. And in normal conditions, our compression is on the load side, where we're pushing down on an element if it's supported adequately, and we could turn it 90 degrees and it's the same thing where it's supported top and bottom. in the middle would be where I create this idea of tension and compression. Whereas on a cantilever, it reverse. So we have conditions which talk about notching, and we have conditions which talk about holes. So what I want to do is actually go to the code. Now you've got these illustrations I just flipped through in your workbook, which will explain them. But let me go to my code section to show you what it looks like in terms of the illustration that's actually in the code. Now this is 502.8, R502.8, where it says cutting, drilling, and notching. So the first condition, when we cut a notch, the question is going to be, is the notch on the bearing point or over top of where we're going to bear? When that happens, you can cut up to 1/4 of the actual depth of the member. So it's the second illustration we have here. So we're cutting a notch over top of this double top plate. So it rests on the double top plate and they want to cut a notch on the end. I could go up to 1/4 of the actual depth, whatever this member is in depth, not its nominal depth, its actual depth. Okay. So if I was on the other end and they were going to raise this so it hangs on the double top plate on the other side, here they're going to notch out for that top plate. And again, the joist comes over and rests on the top plate. That could go up to 1/4 of the depth of the actual member as the maximum allowance on the depth. In terms of that notch's length, it can't exceed what is the bearing member. So in this case, let's say we had a 2x4 wall. That would mean 3.5 inches would be the length of the notch, and how deep it could go in couldn't exceed 1/4 of what the depth is. So if that were a 2x4 and I talked 1/4, that means we're only giving you 7/8 of an inch. So it's 1/4 of 3.5 inches. We come up with 7/8 of an inch. You see where I'm going? So if it's the bearing, 1/4 max. If I'm not on the bearing, so I'm inside of the bearing members, I don't want you to cut where the tension compression is the worst, which means dead center. So the middle third of your span, you can't cut notches, either top or bottom. Can't cut them. On the outer thirds, I'm allowing you to cut those notches, but they can't exceed 1/6 of the depth of the member, not 1/4, 1/6. And the length of them is limited to 1/3 of the actual depth of the member. So here again, sometimes it helps to just create a little cheat sheet to keep with you until, you may memorize these when you get out in the field. But otherwise, if you want to just check what those depth limits are, I'd do a little cheat sheet to tell me what those measurements are going to stack up to be. So 1/3, if I were talking, let's take a 2x6 member. Remember, 2x6 is 5.5 inches in actual member measurement. So if I were going to 1/6, that would mean my 7/8 of an inch is the depth. The length could be 1/3, which gets me to an inch and, I don't know, 13/16, something like that in terms of the length of it. So 7/8 inch and 13/16. So it's not much. Not going to give me a lot, but that's going to detail what happens whether it's in the top or the bottom. But I got to be in the outer thirds, and I can't exceed 1/6 or 1/3 in terms of the dimensions on the notches. Y'all with me? And this applies to rafters as well. Okay. So joist, rafters, beams, we're getting to the same conditions. So are you on the bearing? Or am I not on the bearing? Am I out of the middle thirds? I could do notches. Then when I come to drilling holes, now a hole, we want you to put that where you're at that in-between point between high compression and high tension. So what happens is we're talking the middle of the element. Now, we don't restrict you where you run those holes, but they got to be 2 inches apart. If you have a series of them, they have to have 2 inches from the top edge and 2 inches from the bottom edge for the hole. And out of the hole, the max diameter that I give you is 1/3 of the actual depth of that element. So it's similar to what we had for the maximum length of those notches. And if you think about it, I got a hole I'm cutting. Well, this hole you're sliding down to and actually making a notch. So its length could be 1/3, but the depth on a notch, we're only giving you 1/6, unless you're on the bearing, in which case it can be 1/4 in terms of the max height it could have. Questions on the concepts?
Hey, John.
Yes,
This is
sir.
Jason.
Yeah.
In reference to, say, bottom plates on a slab foundation, when it comes to, I've run into a couple times where they'll start building interior walls. There'll be a vent line that comes up, and instead of doing a 2x6 wall to allow for the hole being drilled for the vents and so on and so forth, they'll just cut the bottom plate on either side. Is that acceptable?
Okay, so they're actually missing a continuous bottom plate on the wall.
Correct.
Yeah. Back to if I had my anchorage, because that now becomes an end. And what do we need? We need an anchor bolt how far away?
Less than 12 inches.
Less than 12 and no closer than 3.5.
Correct.
If they ran that or equivalent, then I could call that a wall and I could call this a wall. I would expect that you got your sheathing on the outside, which is continuous across that gap. So it kind of keeps those exterior faces locked together, and then my siding coming down, so I wouldn't see it.
What about interior walls?
Well, interior, what are you going to put? Gypsum board on it?
Yeah.
Yeah. Can I bridge the gap, the distance? My gypsum board typically, no more than 2 foot apart. Yeah, it could work.
Gotcha.
The
right.
nail
Yeah,
plates,
I would want to see
yeah.
a nail plate or something over the top of it. I've talked
Yeah.
to some guys, and that's why our amendment calls for a 2x6 wall on any vent or drain line wall, whether it's interior or exterior, but run into some issues with engineers that, well, no, I'll just do a 2x4 wall here. Well, got to show, like you said, the nail plates, or either that or they're gonna fur it out or something to give you those distances to.
Yeah. And again, the bigger issue there is, what are you requiring in terms of your insulation package and your energy performance, and can they get that with a 2x4 wall? And if I'm running, for example, plumbing pipes there, do I have freeze issues? Am I going to run into problems? Now, I know you're not worried about freezing, but still, what's your energy conservation package call for? Can I get that in a 2x4 wall? That's going to be your other. That's going to be your other end to look at. So, make sense? Any other comments, questions? Okay. Let me catch this back up with where we were going. This was the notching. Remember, notches here in the outer thirds versus on the bearing versus adjacent to it. So it's in the outer third here. And look at our limits based on depths. If we're on the bearing point, now this is using a ledger board here. So there's a beam and a ledger, and this joist is hanging on it. So 2x2 minimum ledger. Wish that were out of the code, but it's allowed. And I can go to 1/4 of the depth as the max cut for the bearing, just for the length of the bearing. That's all I get. I can't run it out into the span any, because as soon as I do that, it's going to be limited to 1/6 in terms of the maximum depth of that cut. So 1/6 of the depth. And then we're looking at our links, not more than 1/3 of the depth of the member. So that gets picked up. Here's our holes, staying 2 inches away from the top, 2 inches away from the bottoms, making sure that the diameter doesn't exceed 1/3. So I have to look at all those conditions together. So I may not be able to get 1/3 because the depth of the member staying 2 and 2 away won't give it to me. So for example, if I had a horizontal element, which we don't recognize in the code for a 2x4 horizontally giving me support, can't use it as a floor system. It can be in an engineered truss, but it can't be an individual rafter. So I wouldn't be able to run a hole in a 2x4 horizontally. We're going to talk about studs in a minute, because I got to stay 2 inches from the top and the bottom. Well, I only got 3.5 inches. So I'm in negative numbers. So I can't run a hole in those, which makes sense. You wouldn't want to cut a 2x4 and then use it from any kind of a load bearing element at that point. But once again, vertically, we got a different story, and we'll get into those. Questions, anybody? All right. There are fastener details. I won't take the time to do fastener details because they're in your code. That's covered in the nailing schedule in the beginning of the wall section. So chapter 6. And this is one you're going to make reference to from all parts of the code. They will send you back to it, but it's table 602.3 bracket 1. It's at the beginning of your wall section, chapter 6. And when you look at that, it gives me options on nails. It gives me roof framing first, then it talks about wall framing, then it talks about floor framing, and then it gets into my sheathing conditions, wall sheathings, floor sheathings, wood structural panel conditions, and we have some alternative nailing schedules afterwards. But that section, we're going to send you there from different parts. For example, the roof framing, we come back here to look for what kind of nails and fasteners am I expecting to see for wood framing. And it'll give you penny weight, which is the old designation for nails. And then it will talk about a diameter and a length on a nail so that you can get some equivalencies. And the idea is to help us out when we're seeing pneumatic nails instead of the hand-driven nails. So that'll give you some help. Code section under floor talks about carrying the load from a load-bearing wall on the floor system. Ideally, you would double up the joists underneath of that load-bearing wall if they're running, again, the same direction, parallel to each other. However, in most cases, I need to get elements up those walls, in which case I may run conduit, piping, electrical wires, and I don't want you drilling through both of the joists sandwiched together. So we space the joists out and then run solid blocking at 4-foot centers, 2x blocking, 4 foot on center maximum, running down that length, and that takes the equivalency to having them sandwiched together directly underneath of the wall. What it does is it ties it into that floor system so that the wall coming down then gets transferred to the floor system, and now we're taking it to exterior walls via those joists that were doubled up. And so that's my expectation from a framing standpoint when you have a bearing wall coming down. We also pick that up if you have any interior braced wall lines. And that's what I want to get into real quick here, is the brace wall line concept. So headers, floor openings. Now this, remember, applies to roof system like skylight openings as well. If I'm cutting an opening, if it is 4 feet or less, then I can use a single header for that opening. I don't have enough joists or rafters coming there to where I need to worry about doubling up the headers. My trimmers are going to be based on where they're located in the span, and typically they're doubled. I don't usually get singles on them, but they're real close to the bearing point that I could get by with singles. But 4 feet or less in width on the opening, single headers. Okay, then when I go to more than 4 feet, then I'm going to have doubled headers and doubled trimmers. on the openings. So that picks up, again, whether it's roof, whether it's floor conditions, and these are the minimums that we're having. There are some conditions, as I mentioned, if I'm real close to the bearing point. So if I'm within 3 feet of my bearing point for that joist, and the opening was no more than 4 feet, it was 4 feet or less, then it could be single trimmers. And likewise, since it's less 4 feet or less, it could be a single header in that case. But that's very specific. I got to be within 3 feet of where the bearing point is. And that's what they're illustrating here. If I'm more than 3 feet, then that's going to be doubled. Or excuse me, my trimmer joists are going to be doubled, and the headers are doubled because the opening was greater than 4. We expect our joists to be supported at the ends so that they won't rotate as the load gets put on them. And that's the purpose of blocking or my band joist or rim joist going around the perimeter of this building. It's to keep those ends from rotating as the loads are put on them. So we expect to see that in balloon framing. I don't know if y'all are seeing any balloon frame structures, but that's not platform construction where I've got a floor platform, wall going on it, floor ceiling platform, roof assembly, another wall on top. This would be my studs go full height on my single story, 2-story, even 3-story homes back in the old days. It'd be a full height stud, and then your floor system comes over with the joist system, and it gets attached to each stud by nailing, and they run a 1-by usually for just a ledger support underneath of that floor system. And anyway, there's an open stud cavity that goes full height on your exterior walls. And in that case, I could run just blocking between them, and I could run those joists over and nail them into the studs. And that's what we have here going on in the one illustration. That's permitted. Now here is a detail for those joists bypassing each other on a central bearing. If I'm in seismic design categories D, then I have to run blocking in between where they're bypassing each other on that support. And that's only for seismic design category D. And the reason is the loads and the forces that may act on it, we want those locked in together laterally so that they won't try to bend, wobble, shift out of the perpendicular mode of carrying the weights. So otherwise, if it was not seismic D, I don't need to put this internal supports. Remember the ends where they're on the exterior walls, that's where my rim joist or my blocking or band joist are, so they will have that support out there. There is a bridging detail. This is just for test takers to give you a heads up. The language in the code says, and this is 502.7.1, it's page 141 in your code book, 502.7.1, and it's talking about this idea of blocking, bridging, not at the ends where I'm supported, but on the interior of those joist spans. And what the language says is if the joists are exceeding 2-inch by 12-inch, I need to have lateral supports. Now remember, this is common frame lumber. So I don't know how many of y'all get 2x14s. And I'm not talking engineered lumber. If it was an engineered lumber, the manufacturer's data tells me what to do with it. This is just talking about just the engineered dressed lumber that we are going to pick up and buy. So this is one you won't find in the real world because, again, if I'm using an engineered lumber, they'll tell me what the bridging, blocking needs to be between them. And they may have blocking members or they may have bridging requirements for going down the length of them. Here it's saying if you exceeded 2x12, it was common dressed lumber, and then I'm looking for some diagonal bridging, some bracing, something at 8-foot centers. So that's a test question only. That's not a real world condition. With me? Okay. So these are examples of what you can do for it. There's some activities. Once again, make sure you read the question. Is it for sleeping room floors? Is it not? Are we center bearing? How many stories? Where is the header located when you're going through? So it's got some practices. The answers are in the back. You'll go through it. Looking real briefly at this, what were my bearings wood to wood? How much bearing do I need a wood element on a wood element? Anybody? 1.5? Y'all with me?
Yes.
Okay. So when I look at these, I see first off, here's an element going past another one on a center joist. When they bypass, what do we need for minimum distance they'll bypass?
3-inch lap.
3-inch lap.
3-inch. They got the 3-inch lap. They're good. How about the bearing?
1.5 inches.
Negative. I got 1.25 inches here. I need that 1.5 inches. The 4 inches were fine. So this one coming over is fine. It's the other one coming in. It's only got 1.25 inches. That's not good. Coming over this girder on this wood element, I need
1.5
inch and a half. We're good. 1x2 ledger. Is that okay?
Negative.
2x2
Yeah.
ledger. Yeah. Tell them to get a joist hanger here. They shouldn't use that anyway, but yeah, code does allow me a 2x2 ledger. So then my girder into the masonry,
3-inch.
3-inch minimum, not 2 to 3 inches. So again, those are the ones you pick up here. And as I said, that's the simple way to remember 1.5 inches, 3 inches. Then you got those covered, and that's going to deal with when I got rafters coming onto masonry or rafters coming onto wood elements, same thing up on the roof. All right. This was looking at joist spans, and y'all can check. Remember, how much for in the outer thirds? What's my max depth?
1/6,
1/6. What's the length?
1/3,
1/3. Yep. And these notches have to be in where?
1/3.
Not
No.
in the middle 1/3. Outer 1/3.
Yeah.
So if I had a 14-foot span and you came 5 foot in,
You'd be in trouble.
you'd be in trouble. You're in the middle third. So I don't let you have that notch there, much less whether it's in spec or not. Okay. And all of those were not on a bearing point. So we would be looking at that 1/6, 1/3 relationship on the notches. And it didn't have any holes in that one. That was real fast, but any questions? All right. I want to move into bracing, or excuse me, wall sections. Now, studs, you're going to find that there's a table, 602.3.5, which is going to give us our stud heights based on stud sizes and what they're supporting. So that will tell me whether I can use a 2x4 stud, for example. If it was the bottom story of a 3-story building, the answer is no. But if it is a 2-story, second floor or top floor, then I could use 2x4s. Otherwise, I'm going to have to increase it, or you're going to have to get somebody to design it and engineer it to make it work. We cut off the lengths, max lengths on a stud at 10 feet. That's not to say that it isn't possible to have studs going higher. And in fact, we do that, especially if they're non-bearing conditions. But what it's looking at is this relationship of how skinny is it? How tall is it? And as I put a taller stud in place and you put loads on it, I need some kind of lateral supports in there, i.e. what we would get with the floor system, for example, to give it stiffness so that it'll hold those loads. That's what we're trying to address. So we are looking for the cutting off those studs generically at 10 feet. Now, there's a couple of footnotes which get me to bearing conditions where I can go taller than that, and I can get up to even 12 feet with some studs. But it's going to limit me on what conditions I'm using it. But take a look at the table, and that will tell you, what we expect to see for studs. Now, using that gets me to an expected performance level in terms of transferring loads on that wall. So my top plates, when I have my double top plates on that wall assembly, in most cases, I want to stagger joints. I want to stagger the breaks so that we can lock in intersecting walls, so that we can lock in corners at the top plates. So my bottom top plate comes in and butts one direction, then the plate that's on top of it on the double top plate is going to go the other way and have the other one extend over top and the other one butt into it. And that way we've kind of locked the corners to keep them from shifting, rotating out. When I have an intersecting wall, I do the same thing. I take one of the top plates and extend it over top of or into that long wall so that the plate's coming over, butt up against it. But then again, I've got my plate locked in, as we see here where the bearing wall, intersecting walls are. And that gives me greater strength for those connections. Where my double top plates break, the bottom double top plate breaking, where the top double top plate breaks, we want a 2-foot offset minimum. For those of y'all in high wind areas or in high seismic areas, prescriptively that may go to 4 feet apart. And there's actually some prescriptive standards which may push us to have as much as 6 feet of separation. And they may even call for a bolt arrangement for locking those in instead of a nail arrangement, so that we don't get a hinge joint occurring at those staggering and offsets. If they're too close, they may end up getting flexure in the wall, and then that's going to cause some failure modes down the road. So we definitely want to keep track of at least that 2 foot of offset. If I can line up my load path such that it will be directly over top of the studs, and by directly over top of, I'm saying within a 1-inch tolerance of the center line to center line, then that would be acceptable to use just a single top plate. And all that's doing is keeping the tops of my studs in the right location and locked together, but my loads are all coming down in line directly on top of each other. So typically we don't see this except for some single-story buildings where I may have some kind of a roof rafter arrangement coming down on top of that single top plate, but it's lined up where the studs are. So again, if I did that, it prescriptively tells me the splice is calling for a metal splice plate, and it's 3 by 6, again, 0.036 of an 36th of an inch in its depth, and I need 6 number 8 penny nails on each side of the splice. So getting a lot of nails in there to keep that thing together. So that's only for this single plate condition. Questions so far? No, doesn't have to. Practically, it will from a nailing standpoint, but from a reality standpoint, no, it could be dead center between my studs. The hard part's going to be, how do I nail those things together? But they don't have to occur over top of the studs. And that's what we're going to get into next, is this idea of my load path coming down. Come on. If I have studs that aren't more than 16 inches on center and my loads are coming down on top of those on a double top plate. So let's take 2x4 wall, 2x4 studs, 16 inches on center, double top plates, and I got load path coming down. then I don't care where those loads hit. All right. That's the first condition. But when I get to being at 24-inch on center studs, now I do care where those loads are coming down in relation to the studs below. If they line up over top, life's good. If not, I need to be within 5 inches of the stud. And if they do, all of them are within 5 inches, life is good. And you don't have to do anything next. If they aren't within 5 inches, if let's say we had 24-inch studs and I've got these spaced out so that they're going to hit dead center on all of these stud spaces, so they're 12 inches away from the studs. Now, just a 2x4 double top plate won't be enough to hold that weight and transfer it to those studs to get it down through the building. So we're going to make you beef up the top plate or put blocking underneath of it. Or as you see, there's an option to go with 3x4s, which by the way are a seismic brace that is standard construction in some parts of the Northwest. We don't see them generically around the country, but 2x6s, upgrade to 2x6 construction, or go to a third top plate 2x4 Ys, run blocking underneath, or we go with a, as we see here, I could run blocking underneath of it, and that just needs to be the same type of member as what you ran on your plate. So if it's 2x4, that could be a 2x4 plate for blocking, or I'm going to go to those 3x4s. So it's only when I'm 26 inches apart, 24 inches apart on my stud spacings and my load coming down, whether that's a floor system or whether that is a rafter or a truss, if that doesn't hit within 5 inches of those studs, so it's hitting somewhere in between there, but greater than 5 inches, then I got to look at that double top plate and make sure it's not just 2x4s. Make sense? Or at least you understand the concept? I guess that's the critical part. You may not see this in parts of your country, depends on how the framing going. But that's the language that we have in the code there. All right. There's nailing patterns. Back to, remember my nailing schedule that I talked about. It's going to tell me how to nail these studs in, whether they are end nailed, face nailed through like this, or whether they are toe nailed in like we're seeing here on the bottom. It'll give you a range of options. So there's a variety of things, and you probably get questions on the exam that are going to say, which is the proper nailing pattern and type of nail to use for putting this element to that element. And you're going to have to look it up on that table and then come up with, okay, which one of those options is the one listed in the answer section? And it may not be the one that you're most commonly familiar with. It may be something odd, but if it's in that table, it's going to be there. Talks about nailing studs together for doubling them up, how we do that. Talks about our corners, attaching the corners together. That's all out of that table. When we get to cutting and taking out our top plate. Now, this wasn't the bottom plate condition that Jason talked about, but this is looking at my top plate. What happens when I cut out more than 50% of the top plate? Now it needs to have a structural tie across the top. Now, this illustration is in your workbook, and it's in the code book, most importantly. And so you can look that up. And what it's going to tell me is how I'm going to deal with the fact that you've cut out more than 50% of that top plate. So it's
Page 185.
185, thank you. Figure 602.6.1. Appreciate that, Dan. So what it shows, and there's some critical points here. Number one, this is 1.5 inches wide by whatever the cut is plus 6 inches minimum each side. So whatever my distance of cut that we took out, I've got to add at least a foot. And I want 6 inches on one side, 6 inches on the other. And in that 6 inches, we're going to have 8 10-penny nails. Now they can be reduced to 1.5 inches in length. They don't have to be, which is equivalent to the joist hanger type nails, the hanger fastener nails. They don't have to be the full depth nail. They could be, but the idea is it's a 10-penny nail and you got to get 8 of them in that 6-inch spacing. Now the trick is doing that practically without splitting that out by putting that many nails in it. So most of the times we expect to see longer than 6 inches so they can space out the nails some. But the reality is the code says it has to be at least 6 inches, meaning that's the minimum. That's the maximum I can make you do. But once again, the distance requirement, 6 inches past the cut. So what we have shown here, they're going to go from this cut 6 inches this direction, and they're going to go from that cut 6 inches that direction and get 8 10-penny nails in each side. 8 10-penny here, 8 10-pennies there. Now that is not the nail plate that's going to protect this pipe from when they put the gypsum board on. So I would need a nail protector, nail plate on this bottom of that top plate to protect it. So that would be another element that needs to be on place. And we didn't address that. That's not a structural element. That's just from a practical, are we going to run a screw or a nail when we put the siding in into that plumbing pipe or
2
that
inches
ductwork?
below the plate.
I
Just
can't
2
hear
inches
you. I'm
below the
sorry.
plate.
2 inches below the plate. What?
Yeah, is what you need there for protecting the pipe. The sole plate,
Yeah, it
bottom and
needs,
top plate is 2 inches below.
meaning it needs to extend past the bottom edge.
Yes.
Is that what you're trying to say?
Yes.
You're exactly right. So this is the structural tie that I'm talking about. Okay, so that is prime for a question on exam. Be aware. And as pointed out, Daniel pointed that out, that's on page 185 of your IRC. It's figure R602.6.1. And it's this illustration, and it will give me, the details that I need for it. Okay, only when I've cut out more than 50% of that top plate. That comes in. All right, now let's look at our bearing walls. And they're illustrated as well. And you're going to find these on page 184, which is the page preceding what we just showed on the double top plates. And keep track of whether it says bearing wall or whether it says non-bearing wall, because we got different requirements. But I'm talking about notching, and I'm talking about boring holes in those studs. Now the notching says that I can put a notch in there as long as I don't exceed 25% of the stud width. So again, back to 25% of a 2x4, we are 1/4. That's 7/8 of an inch. Not much of a notch on a 2x4. 2x6, I get to about 1 3/8 inches when I go 1/4. So that's the max I expect you to have in a notch. I don't want a notch and a hole in the same cross section. You have to treat that as if it was a big notch. And remember, that's only limited to 25% maximum in total. So in reality, you're never going to have a hole and a notch in the same cross section and be permitted per the requirements of this code. Now the holes, we want to stay at least 5/8 of an inch from the edges, and then the holes are limited to 40% of the cross section of the stud width, and that's permitted for my holes. We have conditions such as the kitchen window concept, looking out an exterior wall, where I may need to run my plumbing pipes, and I'm going to drill out more than 40% of that stud. prescriptively, you could get up to 60%. I can't exceed that without some kind of engineering, but I could get up to 60% if I double the stud. I can only go through 2 successive studs that are doubled with that up to 60% cut out for the diameter of a hole. But again, they have to be doubled and they can't go more than 2. I'm still expecting the 5/8 of an inch away from the edges. Now this is for structure. So back to my nail plates that are required, like we were talking about earlier, I still have the concern, if that is a pipe, am I going to penetrate it with my fastener? In which case I need a nail plate there because I'm within 1.5 inches or 1.25 inches, depends on whether it's gas or whether it's plumbing that's in that pipe. So don't lose sight of those. But this is looking at just the structural components. Okay, so the notching doesn't go by the depth. It doesn't have a percentage of the depth. It's looking at this 25%. The notching is limited to a percentage of the depth, which is the 25%. So we're 1/4 of the depth as the max on the notch. For my holes, I've got the percentage of the hole diameter that is going to be back to, is it a bearing? Is it a non-bearing? So this illustration, as I said, it's in your code book, page 184, 602.6, bracket 1, and it tells me for bearing studs. All right, just
What are the repair options for those?
get an engineer.
Okay.
No, seriously, we don't have repair options.
Okay.
Yeah, there are manufactured products. You may have seen the sleeves,
Yeah.
that go over top of them. That's
Mm-hmm.
splice my stub together. Yeah, there's those kind of fixes that are available, but the code prescriptively says, I don't have any fixes for you. Sorry, if you screwed it up, you're going to have to get somebody to design it or get some kind of engineered fix.
So okay, so when a plumber over notches and over bores, and even if they use those those pre-engineered products, that's still, you need someone with a stamp and a seal to certify those.
Okay, let me back up there. What I'm talking about is, as the code official, you have the authority to look and say, do I have enough justification with the engineering data that was given to me? Do I feel comfortable this will address the issue? And you can accept that. So what I'm saying is, yeah, I want to see manufacturer's data on that splice plate, that fix, that shoe detail, whatever it is, to see, is that what it's intended for? Will it cover this condition, or are there limitations on it? If, for example, may be limited to top stories or single-story buildings. It may not do the bottom floor of a 3-story building, for example. So I need to look at it situationally and see if it covers it. If so, it's got engineering behind it. It just doesn't have my local engineer. So I'm not saying that I'm going to require you to get the local engineer in that case. But if they wanted to make their own or come up with something that wasn't a common product, and they're bringing it to you saying, hey, we engineered it, it's okay, I'm going to say, well, let me see somebody who has legitimacy. And that's where your state's going to say, bring me the registered design professional from my state. Does that make sense?
Yep.
Okay. Hope so. All right. So there is an adjacent table which talks about, or a figure which talks about non-bearing walls. So don't confuse the two, because I can go up to 60% without a problem on those holes, for example, in the non-bearing wall. And again, think about it. All they're doing is just holding up the weight of the sheathing materials, the interior finish materials. They're not carrying weight from above, so they can get more cut out of them and still be legitimate. So there's 2 illustrations there. Don't mix them up when you're trying to look for answers. Okay, header inspections. We already went over the idea of header inspections. Wall bracing we're going to get to in just a minute. This is showing one type of wall bracing. This is the old school, what's called a let-in brace. One by material that starts at the top corner of your corners of a wood frame, and it gets recessed in and it gets nailed at each stud. Then the modern equivalent is that little metal T-shaped bracing, which gets a scarf cut with a saw blade, and then it shoves into the saw blade's cut, and it performs the same function. Either one of those are considered the same thing when it comes to let-in bracing. Now that is going to be LIB bracing method when we look at 602.10, our wall bracing section. So they're the first step in allowable options for bracing. It's not okay for all the floors in my structure. It's only good on certain floors. And we'll talk about that when we get to the wall bracing section. I just wanted to show this illustration so that we didn't get too far ahead. And then we get into this idea of fire blocking. So fire blocking is, by definition, cutting off concealed combustible spaces where I have an intersection between a vertical and a horizontal concealed space. So what it's looking for is, depending on my type of construction, I may be having an intersection with some kind of horizontal element like a ceiling floor system coming over to a wall element, and I need to cut those off from having direct communication with each other via holes, gaps, openings. Now with normal platform construction, I've got a double top plate and I've got a bottom plate. So the vertical channels that are the stud spaces don't connect in to my horizontal channels, which are the joist spaces. So as long as they're intact and they're in place, I shouldn't have a problem and a need for extra materials called fire blocking. However, you got to watch when you do a boxed in soffit or furred down ceiling, which may bypass that double top plate with an opening that could connect those two elements together. In which case, then I need some degree of fire blocking. Now, fire blocking is nominal 2-inch lumber, or as we see here on the slide, an equivalent pieces, and these are spelled out in 302.11 of your code book. Any of those elements constitute fire blocking. You don't have to get into a bunch of different concerns about, oh, is this a fire blocking material? The laundry list is there. If you use those, they're acceptable. So I'm looking for these connections between combustible spaces that are connected vertically to horizontal spaces. And this is just showing you some of those options for, a nominal block, 2 inches, 2 layers of nominal 1-inch material. Again, I can stagger joints on wood structural panels and use it. There's even the idea of the fiberglass insulation, which is going to be at least 16 inches in height, but the full width of the stud cavity, and that it is put in place to close off that gap. Those are permitted. Now here's some illustrations of where you need to be careful. They've got a cove ceiling. It's got a curve in the ceiling corner on the inside of the building. So at that point, I'd come up the studs, and if I didn't have this fire blocking here in between those studs, if I just had my top plate up here, there would be an opening before I hit the top plate, which would allow me to go and connect into these through the ceiling finish into this joist space. So that would be why they needed to run that fire blocking. Here's a better example, I think, when we have a dropped ceiling, or maybe you have a boxed in soffit around the perimeter of the room. So my studs come up, and then there's a gap where it hits this drop ceiling, and that connects in and opens into my floor space.
Fireplace, John, the
Yes.
fireplaces, when they frame it right up against those interior walls, that's a perfect example right there where you need a fire block.
Yep. And my chimneys call for my gap between the masonry chimney, for example, and the combustible framing. And so that calls for that air gap. Well, that means I need to run a fire block in there, which means, is it going to be combustible? No, not in that case. That would defeat the whole purpose. I got to stay so far away from combustibles, 2 inches from combustibles for materials. So my fire block would have to be a non-combustible fire block. And keep in mind what it's doing. All it's doing is closing off that gap so that there isn't a free passage of fire through the gap that's concealed so that we wouldn't be aware that it's taking that path in the
It's
construction.
basically at the draft is what you're trying to do, the draft, air draft through there. So it
Yes.
doesn't travel through other partition walls or any concealed places.
Yes, I'm trying to prevent it from moving through there without having to build up enough heat and time to burn through that element in order to get past it. So we want to cut down. Now, where we run into the floor systems that we may not think about is when we have tubs and they're up against, say, a party wall, joint wall, where I'm going to have a wall cavity here. So the floor system coming up to get around my plumbing traps goes into the supply wall on the tub, and that would have an opening between the horizontal floor joists going up past the tub into now my stud wall assembly. And that's where we would look for fire blocking, which it's hard to get wood elements to cut around all those. So that's where my insulation came in. That's where typically we would use the packing that with the fiberglass insulation in that case. Another one, which normally is not a problem, but check your stairs where they're concealed. If I had stairs that had gypsum board along the bottom of the stairs and there would be channels along the stairs, it's not a true vertical, but it's on a pitch, and that may allow for connections of horizontal vertically through the stair to another horizontal. And so we would look for some kind of fire block. Normally I've got my headers there heading off that opening, and they would close that off. So it's not usually a big problem. Here it's showing that fireplace that Franco was talking about there. We're going to look at those and look for a non-combustible fire blocking material at that place to make sure that we've maintained that gap closure around our pipes, penetrations through the floor system, just making sure they're sealed off. It can be a fire stopping, that's a caulking material that can go in there. And this is showing again that non-combustible caulks around the chimneys and fireplaces. And then you got some practices. Once again, you're going to check these. You're going to look at your spans, going to look at the sizing of my girders and my header. Going to look at my fastening schedule if I have them. There's a lot of things to look at. There isn't an awful lot that you need to be worried about, but that comes into play. All right. Questions? Anybody? Hey, I'm glad. I hope it helped, seriously. All right, this is a good point. I'm going to switch over to my other slide deck. So why don't we go ahead and take a break? I've been about an hour now talking at you, and apologize for screwing up on the lunch. I hope that didn't impact anybody too much. But as my son mentioned to me, he said, well, maybe you were just afraid everybody's going to get hangry. Y'all know what that is, right? Being hungry and getting angry because you're hungry. So Lord knows I don't want anybody getting hangry. So let's keep it to a short break. So how about just 10 minutes, please? I've got the top of the hour, so it's 2 o'clock Eastern time. We're going to meet at 2:10 Eastern time. What you got going on there, Edwin? What time is it?
It's 12 here in Colorado. It's 12.
Okay. Again, 10 minutes after, please come back.